Okay, we're in business.
Awesome. Thanks, Karin, and thanks everyone for joining this. Um, as Karin mentioned, brief review on the agenda. So we'll start with like the what are all the things that we accomplished in 2020. The second section will be all the power of indexing, what makes Pinot fast. Stay tuned for this section. There is a lot of awesome things that we will be talking about. All the cool indexing techniques in Pinot and when to use that. And the last, we will talk about all the things that we are planning for 2021. At the same time, we will be publishing the polling app where you can select the features and vote for the ones that you're exactly excited and looking forward to. Um, Wanted to really start off with by thanking the community. We had like really amazing turnout this year. There were amazing number of commits that happened throughout consistently throughout the year. And as we started, we were mostly people from LinkedIn and Uber that who were contributing to Pinot. And as you see, we have almost close to 150 people who have contributed over the last year. This is really exciting for us as a author of the project to see the interest in the community and the project. We are greatly looking forward to the kind of continued interest in the project for the next year as well. A little bit about the numbers. So we had seen tremendous interest in the project. So we had almost more than 30,000 downloads over this year, especially once we started providing the Docker images and support for all the cloud native um, all the clouds, different clouds with the Helm charts, Dockers, and Kubernetes support. So that really drove the adoption of Pinot as well. What we started off like 5 to 6 companies that early this year, we have almost more than 35 plus companies using Pinot in production today. As you all seen in the Slack community, we have seen tremendous growth here. We started off with a very small community of like 100 people, and we are almost close to like 800. And last but not the least, we have almost 500,000 lines of code added into Pinot. But we do have a lot of code deleted as well. So we have almost 300 lines of code deleted. So we do believe a lot in cleaning up the tech debt and not accumulating dead code. If you're interested and want to learn more, there is a very active community on Slack. Feel free to join us, and we'll always be happy to help you learn more about Pinot or get it adopted in your company. A little bit, the brief intro on Pinot for those of you who are joining here for the first time. Pinot is a real-time OLAP distributed database. It was primarily built for serving high throughput, low latency analytics. So people who have used LinkedIn, very high, it's very likely that you would have hit Pinot in the backend. Anything that you use, see like who viewed my profile, talent analytics, publisher analytics, campaign analytics, company analytics, any kind of chart that you see, you would most likely have interacted with Pinot. So that's kind of the real power of Pinot to provide low latency at very high throughput. That's what we call it as data products, where you're providing analytics to your end users or customers. That's the Pinot is also used for like internal dashboarding for real-time in order to get real-time insights. And this again powers pretty much all your business metrics that you can use. The last but not the least, the new thing that we have added is the anomaly detection part, where you can actually point a machine towards Pinot, and then it can periodically keep querying Pinot to figure out all the issues in your on the metrics. On the ingestion side, it can ingest data from multiple sources, one from the streaming source and also as well as batch. So Kafka is one of the most prominent ones that we support. On the batch side, we pretty much support all the cloud providers, S3, HDFS, ADSL, and GCS. Um, Before getting into the 2020 accomplishments, I want to sort of let you guys picture how Pinot is organized in terms of the layering. So it always starts off with the sources. You have the stream at the batch source, and then there is an ingestion layer, which basically helps, since Pinot is a derived system, it always needs this ingestion layer to pull data into Pinot. Then you have the storage, indexing, query, and connectors. So the storage and indexing is where, and querying is where most of the query processing layers happen. And we have built a lot of other connectors so that you can use Pinot with like other visualizations, or other systems like Presto and Spark. And we have the cluster management component, and we have uh, done a lot of work on the UI side to make it easier to get started on Pinot, but also operate it at scale. I'll be talking about some of the key features that we have added. I won't be getting into all the details, but one of the biggest change that we did was our UI. So if you kind of look at it right now, so earlier all these operations were supposed to be done using the REST API. Now we have provided a UI on top of it, so you can anywhere from creating the table to adding schema to setting up the indexes. All these things can be done via UI. You can easily debug, you can get into a table, you can look at what the segments are, what's the status, and last but not the least, now you can simply enable and disable indexes, and all these things happen dynamically without having to restart the servers. So we have made all these operations super easy with the new UI, and this is something that a lot of people love it, and we plan to add more features in 2021. Very early this year, we took on a big effort in terms of cleaning up Pinot. As you see the picture in the left, we had a huge dependency mess where because of the way we developed it at LinkedIn, we were very tightly coupled with Kafka, Avro, and Hadoop, because that's kind of the technology stack that we used at LinkedIn. We did a major refactoring where we completely decoupled all these dependencies and added this concept of Pinot SPI, which made it super easy for others to actually contribute and add other connectors. And that's how we actually got lots of connectors like the GCS, HDFS, and Azure connectors, and also S3, which is kind of missing in this picture. Um, and we added a ton of support for other formats as well, such as protobuf, thrift, and JSON, and few other Parquet, and few other formats. So this kind of helps us make changes to Pinot and add more connectors very easily. So this was a big change that we did, and we continue to see the benefits of this. And one of the new things that we will be adding here is the kinesis support. On the query layer, we did a bunch of changes here. So we added a few of the SQL operations that were not there earlier, like having post aggregation, theta sketch. We also went one level deeper and added support for partitioned operators. So this was super important for Pinot, which basically believes in the philosophy of pushing the compute to data compared to the other model, which is pulling the data to the compute. And this partitioned operator was super important for us so that we can push as much compute as possible to where the data is. And we have seen some amazing performance improvement due to this. We have made UDF easier. So we have added a bunch of scalar UDF, and we have also provided this concept of groovy functions where you can easily write, before you actually write the more performant UDF, you can quickly try out with groovy, make sure that your code works, and then you get everything done. And then you can, if performance is a concern at that point, you can actually get in and write the real UDF. It makes the testing and development super easy. We did a lot of improvements. Pinot was already fast, but we realized there were some more low-hanging fruits that we could actually gain. So we did a little bit of optimization on our scanning. So what Pinot initially was optimized was purely for random access, because we use indexes. So once index filtering happens, it's not clear that it's always going to be sequential. But as you see here with the dictionary encoding, we kind of made some change so that even with whether it's high, continuous or dense or sparse access patterns, we kind of try to get as much as possible. So we are seeing anywhere from 200 to 800x, 8x improvement from where we were before. So this is really promising, and we continue to invest more in terms of improving the forward index performance. We added a bunch of indexing techniques. This is one of the power of Pinot, the way the system is architected. It makes it super easy for us to add new indexes. I'll talk a little bit more in the next section on what these indexes mean and for performance and when to use them. So these are the three that we added. We are also adding a few more um, late this year and or early next year. Um, Startree is one of the unique indexing techniques that's only available for in Pinot, right? And it allows you someone to actually do the trade-off between space and time. And as you look at it, there are always these two worlds where you pre-compute everything, or you just do the computation on the fly. And Startree is a unique technique here, which allows you to get the best of both worlds without paying a lot of cost. And as you see on the graph on the other side, the pre-aggregation, the storage cost is very, very high. And you get a good latency there, but at the same time, you're paying very high storage cost. And as you add more dimensions, it's exponential in nature. And Startree gives you this in between spot by just sometimes just doubling the size of some of the indexes. You get very, very good performance. So this is one of the numbers that we got from Confluera. So if you look at it, you can something that actually takes 21 seconds to come to sum up data for a month. You can actually do it with 65 milliseconds, right? So that's the power of Startree, and this comes without a lot of cost. One other thing that we did in as part of Startree is our initial version was limited to just building one Startree or a smart materialist view here. But with this new feature, you are now able to add a lot more views on top of the same table. And the query is smart enough to pick the right view based on the query. So this is super useful. And in terms of adding a new star tree, earlier you had to rebootstrap the data. Now you don't have to do it. You simply change the table config, click on reload, and then your star tree index is automatically generated. So it makes the testing and everything and operations super easy. And you can basically add new index without even having a downtime. This is one of the most awaited features in Pinot. So as you all know, Pinot was initially immutable. So which means once the data is pushed into Pinot, you can't really change it. But with the upsert feature, now you can actually change the rows change the state of a row, right? If you look at this is a Uber Eats use case. Earlier, before the upsert feature, you could see for the same order ID, the status keeps changing. It went from created, assigned to assign, and then it's a pickup completed, right? And when you query something for that particular, you would get all the different status, but you can't really figure out what is the latest status unless you do a window function, which kind of makes the query performance really slow. Now, after this, if you kind of look at it, it's the same query with just a flag turned on the table that upsert enabled. Once you have that, you just get the latest status. The power of this is you still have the ability to get all the changes. So you can add an option as part of the query to say that I want all the changes that happen to this particular order. So having this combination of getting the changes that happen to a particular key, as well as getting the latest state, is super powerful. What this means is now you can point Pinot to any of the database change logs, pull the data in, and then be able to get analytics on top of the latest snapshot of the data. Um, Tiered storage is another one. So here, what we had earlier was pretty much a uniform tier. We didn't have the notion of RAM, disk, and SSD, or even getting to the S3 model. And one thing that we have introduced here is like a time-based automatic tiering concept. So you can simply configure in your table that, hey, after 2 days, we need to move the segments to a next tier, and after 15 days we need to move to the next year. And you just put this in the configuration in table, and then we automatically keep in the background, we keep moving the segments around to different nodes. So you can tag your nodes saying that these are SSDs, these are disk, and these are RAM powered. So it automatically takes care of the movement of segments in the background. Other cool thing that we did both in terms of Presto DB and Presto SQL is building this smart connector from Presto and Spark as well. What this allows is you get the power of Pinot, but at the same time the flexibility that Presto provides in terms of full SQL capabilities. And this can be used for ad hoc analysis in the company. So if you look at the top, now you kind of capture the entire analytical landscape from ad hoc analytics to internal visualization to external data products and even machine generated queries like anomaly detection. So you kind of just having Pinot and Presto together, you are able to get a um, lot of use cases solved with this setup. So just to summarize, these are all the things that we did. I haven't gone into the details of a lot of the things that we have worked on, but overall, there is tons and tons of changes that went into Pinot, and thanks to the community and all the contributors here who have actually told us what is important for Pinot, and at the same time have helped us a lot in terms of either be it testing or be it contribution in terms of PR reviews, documentation. We are super happy for for all the support that we have got from the community. Let me see. All right. So I will quickly change over to the indexing.
Does anybody have any questions up until this point that you'd have for Kishore? And if you do, you can, like I said, you can just drop them in the chat. Please don't be shy. Questions are very good things.
All right. So let's get started on the indexing. So quick overview of how data gets pushed into Pinot. You have the concept of raw data, and typically once you have that, that gets broken up into smaller chunks, what we call it as segments. And these segments come into the servers, and this is controlled by the assignment strategy. And once they come into Pinot servers, the brokers are ready to serve this data, and the queries come to the broker, and the broker picks up the right servers and the segments to process the query. This is kind of at a very high level, what are all the sequences that is involved in a query processing. So as you see, the query comes to broker, and the broker computes the routing table, and then it figures out it does the scatter gather, and then gets all the responses back from the servers, and then sends them back to the client. This is at a very high level, but then there is a lot of things that happen behind the scenes here, and that's kind of what is listed in this section on figure out where does the actual latency come from, right? When you look at a query and some queries are fast, some queries are slow, what is exactly happening behind the scenes, right? So for that, I will just walk you through the each individual steps. So the first thing that happens when a query comes is like, hey, what are all the servers where this data is hosted for this particular table? And that's where your tenancy comes into concept, and you can say that I want these segments for this particular table to be residing only on these 3 tables or 5 servers. And the second thing that happens is broker now figures out what are all the segments that needs to be queried, and can I actually prune some of them. Like for example, if some of the segments are doesn't really match the time in the query, you can throw them out. You don't really have to query that. um, and the third part, the server sends these queries to all these servers, and the servers can now do further pruning. It can look at the metadata, it can look at some of the indexes and additional information that is stored on per segment basis, and it can prune the segments. And the last, after once all the pruning is done, you find what are the actual rows that match the query predicate, or the filter predicate in the query. And the last is like processing the actual match rows, right? So this is where your aggregation or group by or selection or any other UDF that gets run. And if you kind of look at all these things, it's the 5 and 6 is actually the most time consuming thing. That's where majority of the time for a latency will be spent. But that doesn't mean that 1, 2, 3, 4 are not important, because what 1, 2, and 1 to 4 steps are doing is actually trying to minimize the amount of work done in 5 and 6. So the more you prune, the more effective the pruning is in 1 to 4, the lesser the time that will be spent in 5 and 6. So in a nutshell, your query optimization is nothing but minimizing the amount of work done in this entire sequence of steps. So for this, Pinot has a ton of things that can be ton of features available to optimize this. So first, let's talk about pruning the servers, which is like I have 100 servers. How can I only query 10, right? Because this is super important when you try to improve your latency, even especially at very high throughput. So this has two techniques in Pinot. One is the assignment strategy, and the other one is the routing strategy. So the assignment strategy is typically tag based, and then you also have concept of partition based assignment and replica group. There are tons of strategies here that you can use as the QPS keeps increasing. Um, the second part is the routing. Since we have multiple replicas, we can actually pick any combination of the servers. So you can actually say in the routing strategy, pick the minimal number of servers required for a query, or you pick the maximum number of queries servers that is possible. So there are all these techniques that are available for you to figure out based on the use cases. And typically, most of these strategies come into play when the QPS increases a lot. The second the second part is like, how do you prune the segments here? So here, if you kind of look at it, you start with all the segments, and then there is a broker side pruning and then the server side pruning. The classic techniques that get applied here are like time partitioning, or you partition on your key. Let's say in case of LinkedIn, we partition the data on member ID, or you can use things like Bloom filter or the metadata based pruning, right? So this is the next level. After you minimize the servers, you try to minimize the segments. And the next thing that you try to do is like, how do I minimize the number of rows that needs to be scanned, right? And this is where all the indexing techniques come into picture. So Pinot has like 5, and then we are adding 2 more in terms of sorted index, inverted range, text, JSON. So I will talk about like when to use what and how these actually affect the latency. And last but not the least is where you try to optimize the latency beyond the filtering. So let's say you're trying to query for some number of impressions in US. Inverted index has done a good job of trying to find all the impressions that come from US, but because of the data size, because of the data profile, 50% of the impressions might be coming from US. So inverted index will not really help much in terms of the latency here. And that's where star tree index comes into picture, where you can do some pre-aggregation, and that's actually smart. It's not exactly the full cube computation. So let's look at what does Pinot actually provide. So unlike the traditional databases which provide this explain plan where someone needs to go and look at it and then say, oh, this is the actual operator tree, and now I need to change it, I need to rewrite the query and other things. Pinot is much more simpler. What it actually does is, for every query, it just tells the stats on what's happening in the query. So as you look at this, in this particular case, it's saying we queried 10 servers, and there were 200 segments that were queried. Of that, 100 segments matched, and matched after pruning, we got only 100 segments. And then even after the server side pruning, we got 50 segments. And what's the work done in filtering? What's the work done post filter? And if you kind of look at all these things, you basically get, if you look at map it to the previous slide that I said, it's almost like a funnel. It's like you start with a server, get to segments, and then get to rows, and then the post filtering. So this is where all the techniques come into picture, right? So for the pruning, you have this assignment, routing, time partitioning key, Bloom filter, and metadata. So all of this is geared towards pruning, how efficient your pruning is. And typically when you see your query and then you see that there are 1,000 segments, but all of them get matched, all of them get processed, that means you haven't really utilized all these techniques. So you might end up putting partitioning or better time partitioning, or even adding Bloom filters here. So the next section is the indexing, right? So if you see this, and if there is a very high number in the number of entries scanned in filter, that means you haven't really applied a good indexing technique. So you look at sorted, inverted. I'll talk about when to use what in the next section. But typically you want to get this as low as possible, closer to zero. And the last one is, if the post filter is very high, that's when you apply techniques like star tree to bring this as low as possible. So in the end, if you kind of look at your query, you always start off with the last part, which is how much is spent in filter and how much is spent post filter. And that's typically gives you the work done for your entire query. And your optimization technique is really trying to minimize this as much as possible. Yeah, so the next section here is like, we have all these techniques, when to use what, right? And typically you can end up just trying to turn on everything, because Pinot's planning is also quite smart to figure out what to use when. So it's possible that you can have multiple indexes for some of the columns, but that's not really advisable if you want to save on some of the storage. So I will explain this through a use case here. What we did is we took the GitHub data set for 5 years, and this has like 2.6 billion rows and 400 GB data, right? And this is the schema. I won't get into the details. It's not too interesting for this, but happy to share this after the call if someone wants to play around with it and then do your own analysis on how indexes helps. So what we did is we took 5 queries, and then we took one single node. We loaded everything in just one node. We gave 16 GB RAM, is just one core. And the reason why we picked one core is we don't want the parallelism to kick in. So it's almost like sequential access processing. So that way it kind of, the time is really telling the acts as a proxy for the work done. Because if you kind of put 32 cores, it's like the number of the time will shrink by 32, so you won't really get the real um, uh, picture of the actual amount of work done. So we used one core here, and the total data size is like 400 GB. So let's look at the first thing, which is part-time partitioning. So this is not new. I mean, time partitioning has been there for quite some time, but it's still very, very useful. So it just says shows the power of time partitioning, right? So if you just, let's say if there was no time partitioning and you end up scanning all the data, a simple query which is, hey, how many events happened between 2018 September to December, right? So something like that would take like 32 seconds, and with just time partitioning enabled, you would come down to like 1 second, right? So that's kind of the power of time partitioning. The second one is the Bloom filter, right? So this is a different query as you look at on the top, which is how many commits has this person done, right? Whatever the actor ID is. So if you just try to raw scan this data, you basically end up with like 2 seconds. But with just adding the Bloom filter on top of it, you get like 1.3 seconds. Note that even with the raw scan, we have done, Pinot has a lot of optimizations that we couldn't really turn it off. Typically, even this should more or less be along almost 30 seconds if you kind of look at it, but there are some optimizations that we automatically do even with raw scan. So that's why the time is like 2 seconds. But if you add a Bloom filter on top of it, this is like a very simple one to try out. It's a very small thing in size, but it gives a pretty good accuracy. So you're able to cut down the latency by almost half here. This is where it starts getting interesting with Pinot, which is the concept of star tree. So the sorted index. Sorted index is almost like your B tree index. We can create it on one of the columns, but only one, right? We cannot create more than one sorted index on a table, which is very similar to the B tree concept. And if you look at here, it's like it went from almost 2 seconds to 15 milliseconds. So that's the real power of the sorted index. It's actually, as you see the number here, the num entry scanned in filter, it's almost zero, right? That's because we kind of sorted index as acts as both the data storage as well as the inverted index. Can't get into too much of details here, but you can think of in your head as like visualize a B tree and how you can quickly figure out the locality where this data starts and ends.
Sure, just a quick heads up. I think that we should probably try to get through this part quickly, just so make sure that we have enough time for the next
Yeah.
segment.
The second part is the inverted index. So as you see here, it's almost the same as the raw scan. So you can guess as the sorted index. The key difference here is this adds a lot of storage overhead compared to the sorted index. So you are able to get, even though you are able to get the same performance, you are adding a lot more storage. The next one is the key partitioning. So the nice thing about this is since you can only have one sorted index, you might want to add the partitioning as well on top of that. And if you just partition it without even adding sorted index or inverted index, you kind of come down to like 5 seconds here. And this is like now the concept of combining different indexes. So if you add key and sorted together, you can now come to like 7 milliseconds from 30 seconds, right? So this is all these things. Just looking at the num entry scanned in filter, you can see that there's a lot of work that is done in the raw scan, whereas with partition and sorted, there is very little work done. The other type of queries here. So if you look at, let's say I want to know all the GitHub events where the number of lines that got changed were more than 1,000 lines, right? So with the raw scan, you take like 40 seconds. Now range index is a much smarter index. It's not like the classic inverted index. So it kind of automatically picks the different ranges that needs to be created. And you get like 3 seconds, here from going from 40 to 3 seconds. The text index is another thing that we recently added. So let's say if you want to get all the pull requests that have title Pinot, right? And then the ROS can basically just looks at every row and then tries to do a regex. And this takes like 155 seconds here, which is quite, sorry, 15 seconds. And whereas with text index, it's just 126 milliseconds. Of course, these text indexes come with the cost, but then if you, in terms of storage, but you get amazing performance here. Last but not the least, this is the star tree index. As I said, if with just inverted index, there is only so much we can push. So in this particular case, you can go from 30 seconds to 7 seconds with inverted index. But as you see with star tree, you can go to almost close to 50 milliseconds here, right? So that's allows you to do lot more work in terms of QPS, support a lot more QPS than the inverted index or the raw scan. So these are all the different techniques. I mean, there is a lot to digest here, but feel free to take a look at it, take the use case and then play with it and then see what would be the right use case for right indexing technique that you should use for your use case. More indexing to come. So we are almost pretty close in terms of adding JSON indexing. So now you can query within a nested column. And we will also be adding geo indexing very soon. That's pretty much on the indexing. So let's get started on the roadmap.
Before we get started on the roadmap, Neha, do you want to jump in real quick? We can do a couple of the questions.
Sure. So Kishore, we have about 4 questions. We can maybe address them before we get into the roadmap.
Sure.
The first one is there benchmark testing done so far? And the results found somewhere?
Yes. So we do have a Pinot benchmark in the Pinot contrib under Pinot source directory. But it's kind of a bit old, but whatever we have right now, we will be publishing that from this.
And the next question is there an API to index data? I know you talked about it earlier, about supporting it in the future.
In order to index it's purely changing the table config. I'm not sure if when the user is asking about indexing or segment generation. If it is just indexing, it's just change the table config and reload the segments, which is just an API call, and then the indexes get generated.
No, Kishore, I was referring to like to load the data into the database. I know like Kafka should be used, right? So
Yes.
if you want to ingest real time, so that's what I was asking about, an API to push data in.
Yes, so we
with
don't
other
have.
streaming platforms.
Correct. So yeah, Pinot doesn't really have the right API today. The right API is through Kafka. So since it's a derived, you point Pinot to any of the pub subsystems, and then it will be able to ingest it from Kafka or Kinesis in the future. So we don't have a right API today. That's something that we plan to add in 2021.
Cool. So the next question is, what approaches can be used to benefit from star tree indexing when dimensions have very high cardinality?
So typically when you have very high cardinality, star tree doesn't really help a lot because if you have very high cardinality, that means the per row number of rows that match per item is very low. So inverted index works very well. Star tree actually helps a lot in low cardinality items. It's actually a little bit counterintuitive, but that's how it actually, the skewness and the low cardinality is where star tree actually works very well.
And the last question right now is, what are the limitations of writing custom functions? What's easy and what's hard?
So we have different levels of writing custom functions. One is like the advanced, which is quite hard, but that's kind of where you get the best performance because it does vectorization and things like that, which is block level processing, array level, using arrays as much as possible. And then there is a scalar, which is like a pure method that you can just add to the class path and annotate it with the add scalar function annotation. That is not very performant, but it's very easy to get started with. And last but not the least is the groovy functions. I think that's the best because you don't really need any code change. You just write your Java code in the groovy function and then try it out. That's probably the best thing to get started with. If your latency is not good in that, then you get to the next two things. Get either to the scalar function or to the block level transform function.
Thanks, Kishore. That's the questions for now. We can probably move on to the next section.
Awesome. So this section, we will kind of talk about all the different layers and also all the things that we plan to do in each of these sections. So since I've been doing most of the talk right now, so in this part, we will actually have each of the champions from the community who's going to lead this feature, talk about it, and then give a brief overview of all the things that we plan to do in this. Yupeng, do you want to get started?
Sure. Thanks, Kishore. Hi, everyone. I'm Yupeng. I'm a software engineer at Uber, leading several streaming systems. Pinot has been a very important component in our real-time architecture, and it's powering many mission-critical business like applications. For example, the restaurant manager for our restaurant owners in the Uber Eats. So 2020 has been a very good year for us to, adding features into Pinot, such as absurd, juice visual feature, deep store, bypass. And we want to continue the investment next year. And the one outstanding feature is this absurd. So this year, we added the support of the real-time ingestion with the row level, the full update. And we want to go beyond the real-time ingestion next year. So one thing is like for the offline table, in addition to user compaction from the offline jobs, we're exploring ways to use the same metadata information to support the absurd. And the next step is to extend this support to the hybrid table, which means we need to establish stronger relationship between the real-time and offline table segments in order to establish this update information between the segments. Another direction is to add the partial update support, which means for the incoming change, we can only include the information to be updated so that we can loop up the previous record and then combine the records. So one challenge on this is that the retention policy is going to matter because if the period records expired, we may no longer have it, right? So that when we do the update, the partial update may fail. So this is one of the things we are looking for next year on Upsert. Can we move on to the next slide? Another thing is about the geo-indexing, as Kishore talked about. I mentioned this in the previous deck. Like Uber by nature has a lot of geospatial information, and we try to establish very strong analytical relationship and derive insights from that. So this year, we added the very basic geospatial support, like the data model, the geospatial functions. And we're looking into adding the indexing support to have a more efficient record retrieval. So the key idea behind this go back to the previous slide, is to use the indexing library called H3, which is open source by Uber, which try to model the geospace using the hexagon, as you can see on the diagram on the right. And this is quite powerful because they can speak up queries like, identify the data points within a given range. So you can think about that on Uber Eats, you have one customer, and then we can show what's the relevant orders from the different other customers in the past hour, right? Which brings like additional real-time information to our end customer. So this geo-indexing, we're going to leverage the hexagon built by the library, and then we can retrieve the data points from this kind of the blue hexagons. The design doc is shown there in the show URL, so feel free to take a look on that. Next slide, please. Another feature we're looking into is to add some very basic join support. Today Pinot has the aggregation, projection, and selection support. A join is always something on our horizon. So the first use case we want to support is this kind of broadcast join, which is join the small table, the dimension table, with a large fact table. So in this example, if we look at the query on the left, we want to join a fact table with dimension table and to retrieve some columns from the dimension table to do declaration. So this type of query, we can do a translation into the query sheet on the right, which end up with the lookup functions that to collect the information from a specific dimension table. So like in Uber, we query Pinot through Presto, so that we hope we can nicely do this translation within the translation layer, and then provide a nice join query shape to our end users. Okay, so this all from us. Back to you, Kishore.
Jackie?
Hi, this is Jackie, and I'm a software engineer, and I have been working on Pinot project for about 5 years now. And this feature is about like creating something like inverted index on the JSON string column. So this index is really powerful to like do some fast lookup for a specific fields within the JSON. So as shown in the example, like for example, we have a column called person, and then in this person we store this plain JSON string, and then with this JSON index, we are able to do things like on the show on the right side. So as we can see, like on the left side, for this record, it's actually nested. So it's a nested array inside an object. So for example, with JSON match filter, so on the right side, it's actually the filter predicate. And then we are able to do things like we want to know all the persons whose name is Adam. And also like we are able to create the like nested fields. For example, it can look up the persons who live in US or who do not live in US or like Canada or something like this. And it can also like do, for example, like we want to look up the persons whose first address is in US. Then you can actually do something like array access. And then also like with multiple arrays, it is able to like flattening all the arrays, and then actually it will do a Cartesian product. So it will end up storing for like underlying records, but it's transparent to users. From users' perspective, it's like it can query like any combinations of these fields, and then this JSON match function is able to return the result. For example, I want to know the persons who live on Main Street and also like playing baseball. Yeah, that's pretty much about this feature. Thanks.
Thanks, Jackie. Elon?
Hey, so yeah, so I just will really quickly go over the stuff that we contributed. The first one is aggregation pushdown, which I recently open sourced, where instead of doing the pass-through queries that we can do in the original Pinot connector, well, that I'll talk about, you can actually enable this through via session property, and it'll turn the query into a broker query and come back, you know, as fast as a broker query does. There's a pull request, and we're actually using it in our production, and it's been working for us. And then second feature, insert into Pinot directly from Presto SQL. We had a lot of data engineers that are mostly just familiar with SQL, so we thought we'd make it easier for them by introducing this feature. And this, you can see in the diagram on the right, Presto segments data into things called splits. And then for each split can have multiple data pages, which are just columnar, it's a columnar format. And the way that we minimize the memory is we shard each row to a different worker based on the date of the segment column. And in a further update, when you have like the append to be hourly, we can do that as well. This way, all the segments are evenly distributed across the workers, and it'll sort the data by each page if you have a sorted index, and then upload it to Pinot. Another feature that we have is create table. This way we have it logged, and we can use the regular SQL workflows that data engineers use. It also does validation to see like if all the columns you defined in your star tree or inverted or Bloom filter columns are all existing before it submits the create table, and it'll create the schema on the table in Pinot. And we can keep further updating it as well. We define the custom properties through table and column properties. So you can define your date time property and, you know, like what indexes you want to use on the table. And then the fourth feature is broker pass-through queries. So normally when you select from a Pinot table, it will either go directly to the servers, and then Presto will do all the aggregation. So that completely, you know, we sacrifice all the great indexing that Pinot has. So what we did is we did a trick where you can put a Pinot query inside double quotes, and it'll use the PQL compiler to compile it into a broker request and do matching on the columns to return the proper types. So this was the first pass, and then we evolved to aggregation pushdown, but there's still things you can do in the broker query that you can't do in a aggregation pushdown, like use custom UDFs and like custom Pinot syntax. And then the next thing I wanted to talk about was the streaming API. So normally when you do a server query, it'll do like a scatter and a gather. But with, for example, when we're using Presto, if somebody wants to select all the data, it makes more sense to just stream it and have only that data in memory instead of building up the result and then pushing the result. That'll just use a lot of memory. And as we evolve the Presto connector, we wanted to have the select for if there are no aggregations. We wanted to have that use the streaming API. Some other features we had is we pushed filters and limits into broker and server queries. I could go on for a long time, but that's pretty much the summary of this stuff.
Awesome.
And we look forward to like contributing more and more as time goes on. We love Pinot at CSS.
Awesome.
Thanks.
And the community is the best. Thanks everyone for all your help all the time.
Thanks, Ilan. All right, Neha.
Cool. So quick update on the tiered storage. In this initial implementation of tiered storage, we so far only support local storage. So we are planning to enhance the support to include deep storage also as a tier. So this will allow us to do things like use S3 as a tier. And as part of this, we'll also be adding support for lazy loading of segments on demand. Next slide, please. So another feature we are planning to work on is derived fields. To understand what derived fields is, let's go through a quick example. So say you have a schema with two columns, IP and cost, and this is how the data in your table is looking. Next slide, please. So suppose you wanted to do some grouping by on the data in your table by some geographical region such as country. So just having IP as is in this table is not really sufficient. You'll have to use some transform UDFs like IP to country. So while that works, it's not the best because with every query that you'll run, this UDF is going to be invoked on each and every row of your data. And this can get pretty expensive very quickly because the same computations are being done again and again. So the only way around this right now would be to re-ingest all your data and also include country as a column the second time that you do re-ingest. But this is not a great solution because re-ingesting means that it's a lot of operational overhead. Next slide, please. So this is where derived functions will come into handy, derived fields, sorry. So you can just add a derived field country in your schema and mark it as derived and set up a function to define exactly how you want to derive this field using the columns that are already existing. Next slide. And when you will reload your Pinot segments, this new derived column will just automatically be available in your table, just like any other regular column. Yeah, that's it from me.
Thanks, Neha. Mayank?
Thanks, Kishore. Hey guys, my name is Mayank. I'm a lead in the big data platform team at LinkedIn, and I've been part of the Apache Pinot team since the early days. So as you guys may know, LinkedIn runs one of the biggest installations of Apache Pinot in production. We are fielding more than 200,000 queries per second in production on indexes of size that run into hundreds of terabytes, which probably means the original data is in the petabyte range. And so that proves the success of Pinot, but that also kind of puts us in a challenging spot where we are having issues keeping up with the new use cases that our clients at LinkedIn want to use Pinot for. And today what happens is there is somewhat of a manual process required where we engage with the customers, figure out their use case, figure out what kind of tuning from Pinot may be needed for it. And this is a very time-intensive process. So one of the efforts we are undertaking is trying to see if we can automate some of this or maybe a lot of this in the effort called smart provisioning. Here, essentially what we are looking at is given a use case which is described based on in terms of its data size, its query pattern, SLA, and so on and so forth. We kind of have toolings or smart toolings that
suggests what a good cluster size, what a good indexing scheme, JVM config tuning, etc. would be. And so that would help us improve developer productivity quite a bit. Byproduct of this also becomes query cost estimation, wherein we can figure out without even running the query how much it would cost in terms of CPU and other resources, which could also have different applications, such as if you were planning to kind of have a billing system, if you had an analytics product wherein you wanted to bill your customers based on the analytics you're providing. This would be a good proxy for that. Another big issue that we face at LinkedIn is some of our clients need to refresh most of their data daily, and the reason, part of the reason being, their upstream gives them snapshots of member data, for example, and this could run into terabytes of data size. And one issue with that is when this huge amount of data is getting refreshed, we are somewhat in a stale state where part of the data is old, part of the data is new, and the query results may be not consistent, which is probably not something that is acceptable by the customers. We're planning to do or support versioning for data pushes to solve two problems. One is once the the new data version is refreshed, we can do an atomic swap on the data side to make sure that we are not answering queries from an inconsistent state of data. But also we have run into production cases where bad data is pushed, and if there's a bad data that's pushed for terabytes, somebody has to go back and run the entire pipeline back again, which may take a lot of time. And you are in this business impacting state for this long time. With versioning support, you can quickly, it's just a flip of a switch for you to get back to the original data version, and that we hope is going to give us a lot of operational stability. Another thing that's we think will be very helpful, Kishore already kind of gave a sneak peek on what happened on this up until now, is the cluster manager UI that we are evolving. We're looking for it as a one-stop shop where whatever Kishore demonstrated is already available, but in future we can add more and more things like loading data via the UI itself. And also, if one of the things that we end up having to deal with when running operations is debugging why the cluster is slow, why a particular query is slow, adding support to be able to debug that would be really nice. Another major area that we want to focus on is security, which is getting more and more important in the analytics domain these days. So just to give a little bit more, set up the context right in terms of why this is important is consider a use case or a product which is hosting first, second, and third party data on a single table, right? For example, you're hosting data from LinkedIn, Microsoft, Google on one single table because you're kind of exposing APIs for them to be able to query analytics on their particular data. For such products, it becomes really important that the data itself is encrypted, because it's not the data that you as the provider of analytics own. So adding support for encryption, not just encryption today at the deep store, which we already support, but also encryption at rest, which means data actually is being served out of encrypted data. And another part of this is essentially going back to the same example that multiple tenants have their data on the same table. They'd like to use encryption keys specific to those tenants. So being able to support that is another thing. Yet another dimension in that is being able to isolate the data across these tenants on a single table, so that even though there will be a encryption key per tenant available, but in the absence in the absence of that, or just as a second level of protection, if we have guarantees that tenant A cannot accidentally query data from tenant B on the same table, is a good security feature to have. On the ECL side, we do have some ECLs already, but we want to enhance those to say that, well, there's a lot of CRUD APIs. Some of them are things like, creating table, updating schema. Those are not necessarily protected through ECLs. But when you run systems in production and you want to go self-serve, that's where these things become important, because you don't want your clients to muck around with each other's table configs and schemas and so on. And the other part of the ECL support is going back to the original use case that I mentioned, is if we can have row level and column level ECLs, that's another way of providing data isolation in that particular example. Yeah, that's all I have, Kishore. Thanks.
Thanks, Mank. That's pretty much what we have. Thanks a lot for everyone for staying. We probably overshot it by almost 10 minutes. This was amazing. Thank you so much. I think we have some questions on the chat. Please feel free to drop out, but we will be available if in case someone needs some questions to be answered.
We can also open it to discussion too. I don't know how flexible you are with this, because I think if anybody has thoughts, then,
yeah,
this might be a good opportunity to share it.
Yeah, so we will be here. So folks who want to stay back, please, we can have open discussion and we will be happy to answer all your questions.
Okay. Do you want to address the first question that's posted there? And then if anybody else has any additional questions, you can either ask it after Kishore addresses this next question, or you can put it in the chat and then we can address it that way too.
What's the question that you're?
It's how does the Pinot team, the Pinot dev team schedule releases, regular time, there's something else at least X times a year, and what's the status of graduating from Apache Incubator?
Yeah, so it's kind of both of them are related. We do have a schedule of almost one release per month right now. So we are trying to cut it down, but because of the process, release process that Apache mandates, it almost takes us 2 weeks from the time we figure out a commit to actually do the release. So it's a bit harder to get below 1 month. So we are trying our best to get it. And it does take a lot of effort right now. So hopefully we can increase our release cadence. On the graduation, we are almost there. It's just a matter of really going through the process of Apache to do the graduation. Hopefully in Q1 we should be graduating there.
Does anybody else have any questions? You can unmute your mic and just.
Hey, Kishore, can I ask you a question?
Sure.
I guess a lot of people will be, when they exploring different solutions, they may ask, what is the difference between Druid? Do you have any highlights about, what is the Pinot doing better and what is maybe doing, maybe the behind or something? I mean, just highlight some like key differences.
Sure. The biggest change comes from the high throughput, low latency use cases. So Pinot was from the ground was designed to serve high throughput use cases and guarantee the low level latency. And as part of that, we have done lots of different things compared to the other alternatives, and star tree index being one of the important ones. Where you basically get the ability to trade off between storage and space. And the other part is the sorted index. And the last one is actually, in spite of having all these different indexing techniques, Pinot has this physical level query optimization, which is for every segment, we look at the metadata, we look at the query, and then we figure out what's the best query plan for that particular segment. So this helps us get the best based on the layout. For example, one segment might have a different layout than the other segment because of whatever reason, but we are able to capitalize on that and then get the best performance there. So all the time, our goal has been to shave off milliseconds here and there. And if you look at all the strategies that we have adopted, routing strategies and assignment strategies, replica group, partition aware. All these things come from the fact that we always try to go towards very, very low latency, even at very high throughput, and maintain that SLA. So that's kind of the biggest difference compared to the alternatives, which more or less geared towards the internal analytics use cases.
Anybody else have questions? You can just unmute yourself and say something. Going once.
So one quick question on the bloom filter. Why can't it be made always on? Because as a space, it takes is less, right? You can configure the error rate.
Yes, not necessarily true. So we have seen use cases where bloom filter will actually be can get quite big, and the on disk formats of bloom filters are not that efficient. And if you kind of even look at adding 1 MB, which is typically the size of the bloom filter, like anywhere from 500 to 1 MB, 500 KB to 1 MB, and then you look at the case where you have almost 10,000 or 20,000 segments per node, it becomes quite expensive. But small scale, yes, you can always enable bloom filters, but we have seen the min-max actually do a pretty good job, and then sorted index is good enough for most of the use cases. But yeah, you're definitely welcome to try out the bloom filter, but it's not a good idea to just add it blindly. It adds a lot of overhead, which is not really needed. But yeah, you can always get started with the bloom filter. It's cheapest way of indexing. I hope that answers your question.
A question here about the indexing matrix and result you showed earlier per query basis. Actually, that's pretty interesting. Actually, internally we discussed about this, and I saw that is those numbers a number of scans in filter and post filter, those definition document anywhere, and then basically because the name itself right now look pretty abstract. So in some sense, so probably we probably need some explanation about what their role is, right? Right. Another thing is that we found pretty useful because there is a to-do, right, or some type of the roadmap item on linking to surface some of these slow query debugging in a cluster management UI. And I think we also have similar feeling. If we add all those most expensive query in terms of this number of scans, right, pop query to the cluster UI in a portable basis, that'd be very useful for debugging purpose. Yes. Because most of the time, the developer can visually see from the queries, right? So what are the index we need to add? We know like what are the queries, which has these expensive scans. But right now, the continuous monitoring part is pretty external to Pinot. We need to plug in other like Kibana. We need to export from the broker log, all places to basically get this insight to the queries to each table.
Yeah, so that's a very fantastic idea. I think.
Yeah, I think we can probably also work by business the idea of linking to add this to the cluster UI. I feel that's a fantastic idea. I think we can service those query level like matrix in terms of those kind of scans. I think once we understand what the meaning of those number of those scanned in filter, post filter, combined with this like servicing, that'd be very powerful.
Yeah, no, totally, and that's kind of what we do. But yeah, I think right now it is limited to the understanding of the developers, and as you rightly pointed, we want to make it so easy to understand that any user can actually parse that and understand that. Yeah, you're absolutely right. Yeah.
Thank you.
Don't forget to upload that feature. I think they have added it on the on the roadmap.
Okay.
Because there are tons and tons of features there, so I think it will help to know that this is going to be important for the users, so that we can prioritize.
Yeah, because we operated for a while. I feel that this is one of the feature we want to see.
Yeah. All right.
Anyone else have questions? Going once. Going twice. Okay.
All right.
Yeah, and if you guys just following up, thank you guys all for attending. This was really good, Kishore. Thank you for hosting it and for everyone who presented and contributed endless contributions. So just to wrap up too, if any of you guys have any thoughts, in the future, you can reach out to like any of the contributors that you saw present today. You can reach out to Kishore, you can reach out to me. If you don't know the name of the person or whatever, we'll be happy to direct you guys. Yeah. And any kind of feedback too that you're interested in, like if it's like feature requests or types of content that you have or whatever, anything like that, please share that as well. And I think that's it probably, right, Kishore?
Yep, that's pretty much it. Thanks a lot, everyone.
Yeah, thank you guys so much for attending. And please feel free to reach out to us about any thoughts that you have ever about anything. Not anything. It's got to be related to Pinot, right? You don't have to give us all your thoughts on everything. But cool. Thank you so much, Kishore. And thank you everyone that contributed and for those who presented. It's really awesome to be part of a community like that.
All right, guys. Take care. See you
All
all
right.
in the
Happy
New Year and happy holidays.
Happy New Year. Bye, y'all.
Bye.